Hi guys, today we're going to do an example where we're going to compute a probability distribution and calculate its mean and variance and standard deviation. All right, so here's my example. A fair coin is flipped 5 times. And the first thing we're going to do is calculate its probability distribution. So you can see I have a little table here. We're going to fill this in. All right, so we're going to start with x. And this will be p of x. And so if we flip a coin 5 times, we can have no heads, 1 head, all the way up to 5 heads. Those are the possibilities. All right, so how do I do this problem? Well, let's think about for a minute. If I was to flip a coin 5 times, what kind of outcomes would happen if I did that? All right, so let's think about S in meaning the sample space, all right, for this particular example. All right, so I could flip 5 heads. I could get head, 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 head. And the next one, I could get 4 heads and a tail. And then I could go on, and at the end, I could get 5 tails. All right, so that is my sample space. All right, so when I'm looking at a sample space like this, are these outcomes, are these equally likely or not? All right, so the answer here is yes, because heads and tails are equally likely. Getting 5 heads is the same probability as getting 4 heads and a tail. So these I've got N of S, which equally likely outcomes. And how many do I have of these equally likely outcomes? So this is a 5-stage problem. We did these before. All right, so how many outcomes are in the first stage? I can either have a head or a tail. And for each of those, after getting a head or tail, I flip it again, and I can get a head or a tail. And the next one could be a head or a tail, and so on and so forth, until I have tossed, or I flipped the coin 5 times. So this is 2 to the 5th, which happens to equal 32. So there's 32 equally likely outcomes when I flip a coin 5 times. All right, so since they're equally likely, what's the probability of each one? Well, the probability for each one of those would be 1 over N of S. So this is, now this is only true when they're all equally likely, but it is true here. So this is going to be 1 over 32. So each outcome is going to, this is going to have probability 1 over 32. So what I can do, I can just count the outcomes for each of these events and multiply that times 1 over 32, and it's going to tell me the probability of each one. All right. So the probability, let's start out with the probability of 0 heads. All right, P of 0. This is the probability of no heads. So this, the only outcome that's going to be associated with that is going to be all tails. That's the only one. So this is going to have probably 1 over 32. Similarly, probability of getting 5 heads is the probability of getting, this guy, right? And that also has probability 1 over 32. So those two are pretty easy. Up here, I'm going to have 1 over 32, 1 over 32. So the next type, let's think about what's the probability of getting one head. So what I need to know here is how many outcomes, what kind of outcomes could have one head. All right, well, I listed one of them. I got 4 heads and a tail. That's one. I'm sorry, that's not one of them. I take that back. I didn't list it. That's one tail, right? So to get one head, I can have head, and then the rest be tails. And then another event that would be similar is for the second one to be the head. So I've got tail, head, tail, tail, tail. And so on and so forth till I get the first 4 to be tails and the last one to be a head. Right, so how many of those are there? All right, so we got the first one's a head, the second one's a head, third one's a head, fourth one's a head, fifth one's a head. There's 5 of those, so there's 5 possibilities, and they all have probability 1 over 32. All right, so that probability is 5 over 32. Similarly, right, the probability of giving 4 heads is going to be similar to that, all right? Because with 4 heads, now I just got 1 tail I got to put somewhere, all right? So I could have the first one be the tail. I could have the second one be a tail, and so on until I get the last one be the tail. And again, there's 5 of those. And they all have probability 1 over 32. So that one as well has probability 5 over 32. Okay, so all right, so probability of 1 is 5 over 32. Probability of 4 is 5 over 32. All right, so now we need to figure out the probability of 2 and 3. All right, so what's the probability of having 2 heads? This one's a little more complicated. I can have the first 2 be heads, and I can keep having the first one be a head, and then the third one be a head, and the rest tails. And then the first one be a head, and the third one be, or the fourth one be a head too. The tail, tail, and so on and so forth. Until I have 3 tails and 2 heads. All right, so how many of them are there? All right, so how many ways, that's what I need to know. I need to know the number of ways to have 2 heads and 3 tails. That's what I need to know. And I'm going to take that value times 1 over 32. Okay, so how can I do that? Well, think about it this way. I've got 5 positions. I've got 5 positions. Here's the first roll, the second roll, the third roll, the fourth roll, and the fifth roll. All right. There's 1, 2. So this is roll 1, roll 2, roll 3, roll 4, and roll 5. All right. So I want 2 of those to be heads and the rest tails. All right. So this is like a combination. All right. I've got 5 positions. And I want to choose 2 of them to be heads. All right. So that number here, this is a combination of 5 choose 2. And what is 5 choose 2? This is the formula for, you know, C and R. If you remember, this is n factorial over r factorial times n minus r factorial. Or another way is that I have r factors on the top and r factors on the bottom. Meaning I'm going to have n times n minus 1. So I get to n minus r plus 1. And this is all over r factorial. Okay. So here I'm going to start with n, so I'm going to have, this is going to be 5 times 4 divided by r factorial, which is 2 times 1. So this is 20 over 2, which is 10. So there's 10 ways to roll 2 heads and 3 tails. And then I'm going to multiply those times 1 over 32. I get 10 over 32. All right, similarly, we get 3, which is going to be the probability of, you know, just replace everything above with tails, tail, tail, head, head, head. And the first 2 be 2 tails. So this is me, I have 3 heads and 2 tails. And then like 2 tails be the first 2, and tail to tail, head, head, etc. So I get just like above. Okay. So this is also going to be 10 times 1 over 32. There's going to be 10 of those as well. All right, so let's go fill on the table. All right, so this is going to be 10 over 32, and this is 10 over 32. There's my probability distribution. I should probably verify that the sum of all the probabilities are 1 and make sure I did all my calculations properly. So I got, you know, 1 over 32 plus 5 over 32 plus 10 over 32 plus 10 over 32 plus 5 plus 1, right? That's these probabilities. There's 1 above is 6, this 10 is 16, 26, and 5 is 31 plus 1 is 32. So yes, this is 32 over 32, which is 1. I'm just verifying that they may not have messed up in what I was calculating. So if that didn't add a 1, that would mean I did something wrong. Okay. So there's my distribution. Right, any questions? Too bad I can't answer. All right. So let's answer the next one. So on average, how many heads will I flip? All right, so we're going to go down here, and I'm going to copy this table that I already made. Copy there. So there's our probability distribution from above. So this is a little reference. All right. So on average, how many would occur? That's going to be the mean. Mu. The mu tells me what happens on average in the long run. So, and the formula for this is the summation of x times its respective probability. All right, so that means I'm going to take 0 times 1 over 32. 1, I'm going to add that to 1 times 5 over 32. Next one is 2, its probability is 10 over 32, and so on and so forth. Right. So this is all over 32. So I got 0 times 1 here. So 0 times 1 is 0. All right. So plus 1 times 5, that's 5. Plus 2 times 10, that's 20. And then I've got 3 times 10 is 30. Plus 4 times 5 is 20. And 5 times 1 is 5. All right, so let's add that up. So we got 5 and 25, 55, 75, 80. 80 divided by 32. And that is, if you put on the calculator, it's going to be 2.5. Now, I could have deduced this mean was going to happen because this distribution is symmetric, right? So if I go right between 2 and 3, the probabilities to the left are the same as the probabilities to the right, except as a mirror image. All right, if we did a graph of this distribution, all right, we have 0, 1, 2, 3, 4, 5. This is x. This is the number of heads. And then over here we have p of x, which is the probability. The biggest one is 10 over 32, so I'll make this one 10 over 32. 32. All right, so 0 is 1 over 32. Right. 1 has probability 5 over 32. 2 has probability 10 over 32. 3 has probability 10 over 32. 4 has probability 5 over 32, and this one has 1. Right. So if I draw like a little dotted line here, if I folded that over, that would be the same on either side of that dotted line. So the median of this distribution is 2.5. And that is also its mean. Okay. So I got my mean. This is 2.5, and the units for this is heads, because my x is in the number of heads. So this says I would get, on average, I would flip 2.5 heads and 2.5 tails. You think it that way. All right. So now I want to calculate the standard deviation. All right, so what is the standard deviation of the number of heads? Where the mu tells me what's going on in average, standard deviation tells me about the spread of the distribution. All right. So, and really, when it says spread, it's how far the value is from the mean. All right. So, in order to get the standard deviation is sigma, and it is the square root of the variance. And the variance is sigma squared. So we're going to calculate the variance first, and then we're going to take its standard deviation to get the standard deviation, or take its square root to get its standard deviation. All right, so sigma squared, the formula for that is that we're going to multiply all the x squareds times their respective probabilities and add them up. And then we're going to subtract, once I get done with that, I'm going to subtract the mean squared. So there's my formula. All right, so sum of x squared times p of x. So the first x is 0. And so I'm going to take that times, I'm going to square it, and then take that times its probability. All right, the next x is 1. And I'm going to square that and take it times its probability, which is 5 over 32. Next one is 2. I'm going to square that times its probability, and so on and so forth. And then I'm going to subtract that mean squared. And the mean we just did. This was mu. The mean is 2.5. So I'm going to subtract 2.5 squared from that, all that. Okay. So again, I have everything over 32. So I get 0 squared times 1, that's 0. 1 squared times 5, 1 squared is 1. Times 5 is 5. 2 squared is 4 times 10 is 40. 3 squared is 9 times 10 is 90. 4 squared is 16 times 5 is 80. And 5 squared is 25 times 1 is 25. And then 2.5 squared, that ends up being 6.25. All right, so I have 0, 5, we got 5, 45, 135, 215, 240. So this is sigma squared. And 240 over 32 happens to be 7.5. So that's 7.5 minus 6.25, and that equals 1.25. All right, and that is sigma squared. Okay. So sigma is the square root of that. And this is going to be the square root of 1.25. And this ends up being 1.118. Okay, so there's my standard deviation. Okay, next one, what's the probability of getting 4 or more heads? All right, so I'm going to look up at my table. All right, the probability of getting 4 heads is 5 over 32. Probability of 5 heads is 1 over 32. So the probability of having 4 or more is going to be 5 plus 1 over 32, which is 6 over 32. Pretty easy. So something like this. The probability that my random variable x is greater or equal to 4, which is p of 4, p of 5. Which is 5 over 32 plus 1 over 32. And 6 over 32 ends up being 0.1875. All right, so almost 19% of the time we will get 4 or 5 heads and 5 rolls, or 5 flips. All right, next question is about the empirical rule. And the empirical rule tells us a couple things. It says at least 90% of the time we're going to be within a couple standard deviations of the mean, and almost all the time we're going to be within 3 standard deviations of the mean. All right, so here, so basically what we're saying here is that 90%, or at least 90%, over 90% of the time. So I want to say 90% of the time, like if I flipped 5 coins over and over again and recorded the number of heads, all right? Over 90% of the time, then my random variable x will be within 2 standard deviations of the mean. Standard deviation, this guy is sigma, and the mean is mu. All right, so that means we think x is in this interval, mu plus or minus 2 sigma, 90% of the time. All right, so let's figure out what this is. So we got mu minus 2 sigma, mu plus 2 sigma. And mu, we said that was 2.5. I'm going to subtract 2 standard deviations, and that is 1.118. This ends up being 0.164 plus 2 sigma, 2.5 plus 2 sigma, and that gives me 4.736. All right, so here's my interval. Now I've got 0.164 to 4.736, right? So I think my x is going to be in there most of the time. So my x only has values, and either equals 0, 1, all the way up to 5, all right? So the values that are, of x that are in here are going to be 1, somewhere around here will be 4. So we got 1, 2, 3, 4. All right. So according to this empirical rule, over 90% of the time, we will have between 1 and 4 heads. But what is that probability? What's the probability that x is within 1 and 4? Right, like this. 1 is less than or equal to x is less than or equal to 4. What is this probability? Well, let's look. All right, so that's going to be, here's all my x's. So that probability, I'm going to just sum up all of these guys. Right, so I can sum those up, or I can 1 minus the other two by the complement rule, which that seems to be easier to me. So that's what I'm going to do. So this equals, P of 1 plus P of 2 plus P of 3 plus P of 4. So I think it's easier to do 1 minus, this would be 1 minus P of 0 minus P of 1, because all of those add up to 1. So this is a 1 minus 1 over 32 minus 1 over 32, and that is 30 over 32. And 30 over 32 equals 0.9375. Which is over 9%. So that is consistent with what we expect. Okay. Also, the second part of the empirical rule says that we expect almost all the time to be within 3 standard deviations of the mean. All right. So we think x is in, mu plus or minus 3 sigma, because that's the mean plus or minus 3 standard deviations, almost all the time. All right. So here, mu again is 2.5. So mu minus 2 sigma, or 3 sigma. This is 2.5 minus 3 times 1.118. And this ends up equaling negative 0.854. And then mu plus 3 sigma is 2.5 plus 3 times 1.118. And that happens to equal 5.854. Okay, so if I do that one, okay, here's negative 0.854 and positive 5.854. And I think, all right, what values of x are in here? Again, x is either 0, 1, 2, 3, 4, or 5. Well, 0 happens to be on the inside of that guy. And 5 happens to be on the inside of that guy. So all of the values that are possible are in there. Right? So this would say, according to this rule, we would expect the number of heads to be between 0 and 5 heads. So what's the probability of that? So what's the actual probability that 0 is less than x equals less than 5? Think about that for a second. What is that probability? So how often, when we roll or we flip a coin 5 times, do we get between 0 and 5 heads? All the time, right? So, in fact, it's almost all the time. It's actually all the time. So we could say, according to empirical rule, close to 100% of the time we'll get between here. But we know that it's actually 1, all right? So this is still consistent. Okay, so that was my review example for the mean and using the mean and the standard deviation calculation and the empirical rule calculation. And so you should be ready, if you got this, to take the quiz that's on Canvas. So feel free to do that anytime between now and Thursday at 1:30. So have a good day. Bye.